All right, today we're going to be talking about trig on the unit circle still, going into day 2 of this. Some of you geniuses might have been thinking, well, we've done all these angles except for angles that land on the x-axis, like 180, 360, pi over 2, 3 pi over 2. What happens if we want to find the trig functions of those? Well, I'm glad you're here to find out. Now, you'll remember me saying that the unit circle is a circle centered at the origin with a radius of 1. You'll notice that our key unit circle angles that are on the x-axis are 0, pi over 2, pi, 3 pi over 2, and 360 over here, or that's 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Today we're going to learn about how to find the 6 trig functions for those key angles. Now, I want you to recognize, first of all, that they land on key points. The unit circle has a radius of 1, so we can identify each of those 4 ordered pairs. I'm going to erase these angles, and we're going to write what those ordered pairs are. Over here to the right, when you go just directly from the origin, right 1, we're going to write that as an ordered pair 1, 0. If you go up on the y-axis, you don't go right or left at all, so the x value is 0, the y value is 1. Over here to the left, where 180 lies, you go left 1, so that's negative 1. You don't go up or down at all, so that's 0. And then down here at 270, or 3 pi over 2, we have the ordered pair 0, because we don't go right or left at all from the origin, and we go down 1, so negative 1. Now you might be wondering, why the heck do we care about those ordered pairs? Well, those ordered pairs actually tell us the sine and cosine values at those values. So the x value represents the cosine. The y value represents the sine at that angle. So for example, if I asked you to find the cosine of 360 degrees, which is right here at 1, 0, you would say that the cosine is 1, the sine is 0. Same thing goes around all the ordered pairs on the x-axis. At 90 degrees, the cosine is 0, the sine is 1. At 180 degrees, or at pi, the cosine is negative 1, the sine is 0. It's a little bit easier than drawing your special right triangles every time. So off to the side, I would definitely write it as an ordered pair. The x value represents the cosine. The y value represents the sine. You can remember this if you say it with a southern accent. Y, sine. They kind of rhyme. Sine, y. So the y value is the sine value. The x value is the cosine value. You can also remember it goes in alphabetical order. C, S. So cosine value comes first. The sine value comes second. Now, what's missing, folks? We've talked about sine and cosine. You obviously don't see a tangent there. So to find the tangent, you have to do a tiny bit more work. To find the tangent, it's the sine divided by the cosine. So you'll just take your ordered pair, take the sine, and divide it by the cosine, or y divided by x to find the tangent value. You might want to put that in a happy little cloud to remind you of it. Now we're going to walk through some examples of x-axis angles. Starting with 180 degrees. Just like yesterday, we're asked to identify all 6 trig functions for the angle that's given on the unit circle. So 180 degrees, you're thinking to yourself, well, 180 degrees is the same location as pi. It lands on an axis. It is directly to the left. I would start out by writing that point as an ordered pair, remembering that the unit circle has a radius of 1. We go left 1, so an x value of 1, and stay there, don't go up or down, so it's 0. Right above it, I would write that this is your cosine, this is your sine value. Remember, it's alphabetical order, CS, or you can remember sine, Y. Sine goes with Y. Okay, now let's find our sine, cosine, and tangent of that angle. The sine, you simply just look at the y value and it is 0. The cosine, you simply look at the x value, it is -1. The tangent is the sine divided by the cosine, or y divided by x. Our y value is 0, our x value is -1. 0 divided by -1 is 0. Now, just a little tidbit sidebar review. Kids always get confused when you have 0 in the numerator, whether it's 0 or not. This is just a little sidebar. If you have 0 in the numerator, that is okay. You can remember 0 in the numerator is equal to 0. If, on the other hand, you have 0 in the denominator, that's a big old no. That would be an answer of undefined. I would put this off to the side because, again, students always forget which one is possible and which one is impossible. 0 in the numerator is 0. That is okay. 0 in the denominator is not okay. No. So it's undefined. Now let's continue on with our 6 trig functions and find the reciprocals. Cosecant is the reciprocal of sine. Now you'll think of that 0 that you see over to the left as over 1. If we take this 0 over 1 and flip it over, we get 1 over 0. 1 over 0 is undefined. So the cosecant at 180 degrees is undefined. The secant is the reciprocal of cosine. Remember, you can take that cosine and stick it over 1. It's a whole number. So we get 1 divided by -1, which is -1. Tangent, its reciprocal is cotangent. So it would be cosine over sine. The cosine is -1. The sine is 0. 0 and the denominator is undefined. So the cotangent is undefined. Now, when we evaluate our unit circle angles, we will never have 30, 60, 45 reference angles will not have undefined answers. But when you start dealing with angles that land on axes, then you will start having answers that are undefined. That will occur if 0 is in the denominator. Let's check out this next one, 3 pi over 2. You should be pretty comfortable recognizing that 3 pi over 2 is an axis angle. It's equivalent to 270 degrees down here on the y-axis. Write that point as an ordered pair, remembering that the unit circle is a circle centered at the origin with a radius of 1. Since to get to this point right here, we don't go right or left at all. The x value is 0. The y value, we go directly down, is -1. Take a minute and label your x value, your cosine, your sine value goes with your y. Remember alphabetical order or sine y. Okay, now we're ready to rock and roll. Find our sine, cosine, and tangent values, and then we'll find the reciprocals after that. Sine is simply the y value, -1. Cosine is the x value of 0. Tangent is sine over cosine, or if you like to think about it as y over x, that is the same thing. We have -1 over 0. 0 in the denominator is undefined. Now let's find the reciprocals. Cosecant, secant, and cotangent. The reciprocal of -1 is -1 over 1, which would just be -1. The reciprocal of 0 is 1 over 0, which is undefined. And tangent's reciprocal, cotangent, would be cosine over sine, which is 0 over -1. 0 in the numerator is okay, it equals 0. So take a look. So another thing I want y'all to recognize. If one value is 0, its reciprocal is undefined. That happens in this case with cosine and with tangent. Let's continue on to the back to do some review of problems like we did yesterday. All the angles that you'll see on this back side are just continued review from yesterday's notes. So just giving us an additional opportunity to practice dealing with angles that don't lie on axes. Starting with 330 degrees. Look at your unit circle and figure out where 330 degrees lands. 330 degrees is almost all the way around the unit circle to 360. 330 lands in the fourth quadrant, and I want you to think about how far 330 is from your x-axis value of 360. You should figure out that your reference angle is 30 degrees. Form a right triangle with your x-axis and fill in the remaining degree. At this point, you should be comfortable filling in your side lengths, recognizing that it's a 30, 60, 90 triangle. Go ahead and fill those in. Now, remember, before finding all 6 trig functions, you should always check to see if your side lengths are appropriate. Remembering that the origin is right here by the reference angle. If we go right, that's a positive root 3. But if we go down on the y-axis, this should be a negative 1. The hypotenuse is always positive. Let's find our sine, cosine, and tangent values using SOHCAHTOA to help us out. If you've gotten in the habit of labeling your O, your A, and your H, remember that O, the opposite, is always the opposite of your reference angle, which is the angle that is snug close to the origin, snug close to the x-axis. Sine, you do the opposite over the hypotenuse, we get negative 1/2. Cosine, adjacent, over the hypotenuse, you should get square root of 3 over 2. Tangent, we get the opposite over the adjacent, you get negative 1 over the square root of 3. Rationalize it out to get negative square root of 3 over 3. Now find the reciprocals. Check yourself before moving on to the next problem. All right, folks, on this next angle, you'll notice that I've given you a negative unit circle angle. So when I give you a negative unit circle angle, negative 3 pi over 4, remember that when we find it, we're starting at the x-axis and we're going backwards. If this is negative pi, we're going negative 3/4 pi. So negative 3/4 of the way there. So think about breaking it into fourths. You have negative pi over 4, negative 2 pi over 4, negative 3 pi over 4 should land in the third quadrant. Even though the angle that is given is negative, our reference angle will always be positive. Anything that ends in pi over 4 has a reference angle of 45 degrees. Fill in your side lengths of your 45, 45, 90 triangle, making sure to watch that your legs might be negative. If you go left on the unit circle, on the coordinate plane, the x values that move to the left are negative. The y values that move down on the coordinate plane are also negative. Just like before, your hypotenuse is always going to be positive. So just to review, when we have a negative angle, you start at the x-axis and go backwards, but it does not affect our reference angle. Our reference angle is still positive. It's still going to be 30, 60, or 45, depending upon the angle that's given. Go ahead and label your opposite, your adjacent, and your hypotenuse so that we can evaluate all 6 trig functions. I'd like you to pause the screen and try to find your sine, cosine, tangent, and all the reciprocal friends. Check your work above. Keep in mind that when you're not in the first quadrant, you're going to have some trig functions that are negative. The last one we're going to look at is 2 pi over 3. Use your unit circle or your knowledge of your unit circle angles to help you find out where 2 pi over 3 lands. Keep in mind this is 0, this is pi, and this is like 2/3 of the way to pi. So it should land in the second quadrant. Oops, it's kind of ugly, sorry. Form your angle, triangle with your x-axis, never with the y-axis, And remember, anything that ends in pi over 3 is going to have a reference angle of 60 degrees. Fill in your other angle, and now let's fill in your side lengths. Across from 31, across from 60 is the square root of 3, the second longest leg, and your hypotenuse is always going to be 2. Before you start labeling, remember, this is your origin. If you go left, it should be a -1. If we go up, that should be a positive square root of 30, positive square root of 3, and your hypotenuse is always positive. Now, go ahead and label your opposite, your adjacent, your hypotenuse, so that you can find all 6 trig functions. And let's evaluate those off to the side. Sine, cosine, tangent. Sine, opposite, over hypotenuse. Cosine, adjacent, over hypotenuse. Tangent, opposite, over adjacent. Simplify that down, you get negative square root of 3. Reciprocal friends, you should get 2 root 3 over 3. The secant, you should get -2. And cotangent, you should get negative square root of 3 over 3 once you rationalize everything out. You'll be practicing some more of these regular unit circle angles, as well as angles that land on axes, on your X or Y axis. Remember to use your ordered pairs for those. Come back to the video if you need some additional help. Also, come to office hours if you have questions. See you soon.